All right, guys, 6.3 is called logarithmic, logarithms and logarithmic functions. Now, in the first two sections of this chapter, we've talked about exponentials, exponential growth, exponential decay, all right? And now we're going to kind of transition a little bit into something called logarithms. Now, the one big thing we need to understand here is that logarithms and exponents, so I'm going to put it right here. I'm going to put exponents and logarithms are inverses. So they undo them each other. Okay, just like squaring and square rooting are inverses, or adding 7 and subtracting 7 are inverses, exponentials and logarithms are inverses of each other. Okay? Now, you guys need to change this. I put logarithms in that table. You guys have something else. I forgot to change that before I printed it, so we should make that logarithms in our chart instead of, what's it say, continually compounding or something like that. Okay, so logarithms. I'm going to write this down and then I can explain it. Okay, write that down and then I'll talk you through it.
Is that a 6 after the log?
That is a B. That is a B. Thank you. That's a B. So this is verbalized log base B of y. Okay, log base B of y equals x. So this is true if and only if b to the x equals y. Okay, so we talked about exponentials a lot, and so we have b to the x equals y. Well, if I take a look over here, the answer to a log is our exponent over here. So I want you to put that right below this. I want you to put in a star the answer to a logarithm is an exponent. Did I spell exponent right? Is there 2 N's or 1 N? Exponent? That's right? Okay, so the answer to this log is an exponent. Okay, so you can definitely see the connection between these two forms. Now, when I start getting into these next two examples, I think that this will make a little bit more sense. Okay, so for example, we want to rewrite each equation in exponential form. Okay, so this is in logarithm form right now, and I had said earlier that the answer to a log is the exponent, right? So this will be written 2 to the 4th power equals 16. So I've rewritten it from log form to exponent form. Now, guys, when we talk about exponents, that big number is called our base, right? And in log form, that small number is called our base. So log base 2 of 16 equals 4. So we have the base of our log and the base of our exponent. That's the same number. The answer of our log is our exponent, and then that big number becomes our equals 2 of our exponent. Okay, so if I look at the second one, I know my base of my exponent is going to be 4. I know the answer to the log is my exponent, so 4 to the 0 power equals 1. Well, if I go back and just go back to this first one example, is 2 to the 4th 16? Yes, it is. Is 4 to the 0 1? Yes, that's true. Anything to the 0 power is 1. All right, so again, here's my base. So 12 to the 1st power equals 12.
Ooh, now you gave us a tricky one with the fractions.
Oh, shoot. Okay, so this is, here's my base, right? 1/4, I'm going to put parentheses around it, to the negative first power, the answer for log is our exponent, equals 4. Is that true though? 1/4 to the negative first power is 4?
Yeah.
How do I get rid of my negative exponents? Move it, right? We're going to flip it in this case, take the reciprocal of it, and that becomes positive 1, and then that's 4. Okay, so all we've done there is just rewrite going from log to exponential. Okay, example 2, we're going to go the other way around. We're going to go from exponential to log. All right, so I'm going to write log, and this is my base, so that's going to be my base there. So log base 5. The answer is my exponent, so that needs to be equals 2, and then that big number is there. So log base 5 of 25 is 2. Okay, this one's a little bit trickier. So log base 10 of 1/10 equals -1. Does 10 to the negative first power equal 1/10? Does 10 to the negative first power equal 1/10? Yes, it does. Again, take it to the bottom, or we'll take the reciprocal of it, be 1/10. All right, so now I have a fractional exponent. Now, remember, guys, here's what I want you to understand. Okay, a fractional exponent, my numerator is my what? My power, right? And my denominator is my root. So this essentially, okay, 8 to the 1/3 power is the cube root of 8. Okay, what's the cube root of 8? 2. Okay, so that's another way to think of it. 8 to the 1/3 is the cube root of 8. Now, when I write this, I'm going to say log base 8, because that's my base, of 2 equals 1/3. Right, and this last one will be log base 6 of 1 over 2/16 equals -3. Questions there? Okay, now let's start evaluating these. You guys, here's what I'll tell you. There is, on this upcoming test, there will be a no calculator portion of the test. Okay? We need to be able to evaluate these and think through these without a calculator. So I encourage us as we work today and work on our assignment today to don't be connected to your calculator, because you're just, probably developing bad habits, because we won't have it on the test. Now some of you might be saying, why is that? Well, we need to know this stuff. And Mr. Jeffer, next year, if you guys take pre-calc, he has a no calculator portion of every test, okay? Every single test. So here's what I want you to think. Log base 4 of 64, really guys, is 4 to what power equals 64? I really think there's benefit to rewriting it like this and thinking about it. 4 to what power is 64? 4 to the 4th? 4 times 4 is 16. 16 times 4 is 64. So the answer here is 3. So log base 4 of 64 is 3. Again, we said the answer to a log is an exponent. 4 to the 3rd power is 64. Okay, now we got this decimal. 2, how do I read this decimal? A lot of us will say 0.2, which that's right, we do that a lot, but how do I really read that? 2/10, right? 2/10, and 2/10 is written like this as a fraction, and Ryan already said it, that can be reduced to a fifth. I really believe, I think it's better to, if you have a decimal, convert it to a fraction, and you'll see why here in a second. So I'm going to say log base 5 of 1/5. Why? Well, now I can think 5 to what power equals 1/5? Well, here's a little trick, guys. If we have, to get from 5 to a 1/5 or a fraction, it has to be negative because we need to flip it. So this is going to be negative 1.
Did you set log 5 equal to 1/5?
Say that again.
Did you set log 5 equal to 1/5?
It's not equal, it's log base 5 of 1/5.
How come on the other one you said equal?
So, okay, so I just rewrote this instead of having 0.2.
Oh.
And then I rewrote it like this, 5 to what exponent, or 5 to 1 power is 1/5. Then I set it equal.
Okay.
Makes sense? I mean, essentially, there is an x out here, guys, kind of. I mean, that's the answer. That's what we're finding. Okay, now I'll go over here. Log base 1/5, so this is going to be 1/5 to what power equals 125. Okay, now, just so we are on the same page here, if I take 1/5 to any power, let's just square it. What's my answer going to be? Well, I square the numerator. What's 1 squared? 1. I square the denominator. 5 squared is 25. So if I square 1/5, or cube 1/5, or take 1/5 to the 4th power, it's always going to be a fraction like that. I don't have a fraction here, do I? What does that tell me about my exponent? It's got to be negative. So how do I get 5 to 125? Or what power? 5 to what power is 125?
Negative 3. Negative 3.
Guys, negative 3. We got to know our cubes. 125 is a perfect cube. 5 times 5 times 5 is 125. So our exponent here, in order to flip it, is going to be negative 3. Okay, now 36 to what power equals 6? Now, am I getting bigger or smaller here, guys? I'm getting smaller. If that is the case, it's going to be a fraction. Now remember, kind of when we talked about all the way up here, I talked about power and root, right? So if it's 1/3, that literally means the cube root. Okay? If it's 1/4, that means the 4th root. If it's 1/2, that means it's the square root. Okay? So how do I get from 36 to 6? 1/2. Isn't 1/2 like square root? What's the square root of 36? 6. Absolutely. 1/2. Okay, top of the next page. Guys, there's two different, I guess you could say, special type of logs. The first one is a common log. Common log is when we have base 10. All right? If we have base 10, well, then we can write that log as this, log of x. Okay? It's kind of like square root. When I have a square root, guys, do I put the 2 here? No, I don't. We just assume, we know that there's a 2 there. Same thing with log. If there's no base, the base is 10. Okay? Now, if I look at my calculator on the left-hand side down towards the bottom, and I actually got my calculator fixed, so I'm excited about that, if I can find it. Let me have you see TI something. What? What? There we go. So if I look over here at the left side, right next to the 7, okay, it says log. So if I hit log, that is log 10. That's log base 10. I can't use that button if it's log base 4 or log base 7. It doesn't work. It's only if it's 10. So if I look here at this example, it says log of 8. Well, that literally means 10 to what power equals 8? 10 to what power equals 8, guys? A decimal. What's 10 to the first power?
10.
It's 10, right? So this answer is going to be some ugly decimal below below 1 or less than 1. So when we don't have a log that works out nice and neat like that, we can use our calculator. So if I just type in log of 10, excuse me, I lied. Log of 8, my fault. Log of 8, and hit enter, the answer is that decimal. So, guys, 10 raised to that answer is going to get me what? That'll give me 8. Okay, that's how you can use our calculator. So in this answer, it would be 0.9. I'll round that out to about 3 decimal places, so it would be 0.903. There'd be our answer. Okay, in our calculator, do log of 12, please. Again, I think that should be greater than 1 because it's greater than 10. Hit enter. 1.079. 1.079. Okay? Now, natural log, all right, is when we have a base of e. So e is, again, 2.71 something, something, something. And we write that differently, guys. It is ln of x. Okay, ln, what is that? I don't know. A log that's natural? I don't know. It's just what it stands for. So if I look at our calculator, our natural log is below the log button. So if I want to do the natural log of 12, just type in natural log of 12 and I get that number. Now, what does that mean, guys? That means e to that exponent is 12. So the answer would be 2.485. 2.485. Ryan.
What does E equal?
E is what we talked about last class, remember? It's 2.71, and it goes on forever. It's that natural number that we approached on our graph there. And again, log, do that for me. Log 0.3, log of 0.3, excuse me, natural log of 0.3, negative 1.204. Negative 1.204.
How do you get natural log again?
Now we've got some properties. We'll use these a little bit today, and also we'll keep using them throughout the chapter. Now, log base b, and again, b is any number, I don't care what it is, but of 1. This means b to what exponent equals 1? B to what exponent or what power equals 1? 0. So I'm just letting you guys know, if that number in our log is 1, the answer is going to be 0. Unless that is 1 as well, but that rarely will happen. Okay, next situation, log base b of b. If those are the same numbers, okay, essentially that means b, okay, to what exponent equals b? 1, right? B to the first power equals b. So if they are both the same, that'll equal 1 100% of the time. Okay, bottom left one here. B to what power equals b to the x? B to what power equals b to the x? Huh? Guys, doesn't this question mark have to be x for it to be equal? B to the x equals b to the x, right? B to what power equals b to the x? It's got to be x. So here's our little shortcut. If our base here and that number are the same, those cancel, and I'm just left with that. Kind of like I did over here, guys. If these are the same, they cancel, and I'm just left with my exponent. What's my exponent there? What's my exponent right here? 1, and that was my answer. Okay, now this one, there are a couple ways to think about it, but I have b to the log base b. Now, we had said that exponents and logs are inverses of each other. We're going to talk about that just more in just a second, but they're going to undo themselves. So if this is the case where I have b to the log base b, and again, they have to be the same, then those are going to cancel, and I'm left with x. Okay, so using these properties, in this first one, I have log base 6 of 6 to the 2x. What's going to happen to log base 6 of 6? It's going to go away, and I'm left with 2x.
You don't have to find x, you just put 2x.
Well, we can't really find x because it's not equal to anything. Does that make sense?
Yeah.
So if there's an equation, which we'll get to later in this chapter, we're going to be solving logarithmic equations, then we're going to have to do that. But since there's not, we're just kind of using some properties to simplify. Okay, log base 8 of 8, what happens here? You go away, I get 1. 8 to the first power is 8. We have 2 to log base 2. What happens there? Go away, and I'm left with 4x. Now this one's a little different, because in order for us to cancel here, what does this have to be? It's got to be a 3, doesn't it? Like we did over here. Our base and that number has got to be the same. Our base and that number has got to be the same. I want this to be 3. Now, can I rewrite 27 to be in terms of 3 to a power? Absolutely, right? So I'm going to rewrite this and say, hey, log base 3 of 3 to the third. Because 3 to the third is just 27. I just rewrote it, and then that's to the x. Well, now, log base 3 of 3, what happens? Cancel, and now I'm left with 3x. So I can rewrite that to get it in terms of our base.
So we always get like just a number and an exponent, or just a number? Or like, will you ever have log in your final answer?
I can't say always. These are 4 examples where logs aren't in there, but we may potentially have those. Okay? Now, guys, graphing logs. We said earlier that logs and exponentials are inverses. What do we remember about inverse functions? We're way earlier in the year, inverse functions. I told the other class, just say something remotely close so I can feel good about myself the rest of the day. They're opposite. What about their graphs? The graphs of inverse functions. Flipped. Flipped over what?
X-axis.
Not quite the x-axis.
The y. No.
They reflect over the line y equals x. Okay? So they reflect over the line y equals x. Does that ring a bell? Just say yes to make me feel good about myself. Okay. That's the line y equals x. Now, in order to find inverses, if we recall, we are going to switch x and y. Okay? Now, here's how we're going to do this, guys. We are going to graph, okay? When we graph this, in order to graph that, we're going to think about this. 3 to the x. Because I can graph 3 to the x pretty darn easy. Okay? Now, these two functions are inverses of each other. 3 to the x, or I could say y equals 3 to the x, and log base 3 of x, they are inverse functions. So if I can graph this one and find the x and y coordinates of this one, and just switch them, I will get that one. Okay? So I'm going to make an x and y table here. -2, -1, 0, 1, and 2. How do I pick those numbers? I'm just picking them. Okay? Now, what's 3 to the 0 power? Thank you, 1. So that means 0, 1 is going to be on the graph. What's 3 to the first power? 3. 3 to the second power? 9. Now, 3 to the negative first power. 1/3, right? We don't like negative exponents. We're going to flip it, take it to the bottom. It's 1/3. 3 to the negative second power is, well, 3 to the negative second. I don't like it. Better take it to the bottom. 1/3 squared. What's 3 squared? 3 squared is 9, so 1/9. Okay, those are the coordinates of 3 to the x. Okay, I'm going to graph that just so we get a visual. So if I plot these, 0, 1, 1, 3, 2, 9, negative 1, 1/3, negative 2, 1/9. Is this graph ever going to cross 0? No, there's a horizontal asymptote. Guys, that's 3 to the x. We've talked about that in section 1. Exponential graphs, that would be an exponential growth, okay, function. Now here's what I'm going to do. That's not our graph of log base 3 to the x. That's not. But what I'm going to do is I'm going to switch my x and my y coordinates. Because we know inverses have that property. So I'm going to make my x's over here now my y's. So negative 2, negative 1, 0, 1, and 2. My x's over here become my y's over here, and my y's over here become my x's. And now I'm going to plot those points. So I'm going to start here kind of in the middle because they're a little bit easier. I'm going to do 1, 0. 1, 0 is right there. 3, 1, and 9, 2. I'm then going to do 1/3, negative 1, and 1/9, negative 2. So if I plot those, the graph is going to look like this. As you can see, the graph is symmetrical over the line y equals x. Okay? So which one's my actual graph though? It's the blue one. This is the graph of y equals log base 3 of x. Okay? This is the graph of 3 to the x. Do I need to graph the red one? No, I don't. Do I need to get my x and y table for the red one? I do. Because I can't get my x and y coordinates, my log, without that. Okay, so plot, I should say, come up with a table of values of 3 to the x, inverse it, flip x and y, and then there's our graph. I grew them up both up there so we could see that, we could see the connection between